first time you saw a picture of an atom? You probably learned a fact that bends your mind a little. It's 99.999% empty space. We look up at the night sky and see a huge, dark ocean separating the stars. The idea of empty is just fundamental to how we see the universe, from the tiniest particles to the biggest galaxies. It feels simple, clean, and obvious. But what if I told you that this basic idea is completely, fundamentally wrong? That all that emptiness we take for granted is actually a lie? The reality hiding in that so-called nothingness is a seething, chaotic storm more bizarre than anything we could have ever imagined. Today, we're tearing down the universe's biggest lie and diving into the true, wild nature of the void. When we imagine empty space, we think of the massive gaps between planets and stars, and especially between galaxies. It seems like a perfect vacuum. But our first step in exposing the lie is realizing that even this space isn't really empty. The vast regions between stars and galaxies are filled with what you could call a cosmic fog. It's incredibly thin, way more sparse than any vacuum we can make on Earth. But it's there. This fog is made of stray atoms, mostly hydrogen and helium, which are leftovers from the Big Bang or particles thrown off by stars. In the deepest parts of intergalactic space, you might find less than 1 hydrogen atom per cubic meter. But when you realize just how gigantic that space is, it all adds up. In fact, most of the normal matter in the universe, the stuff made of protons and neutrons, isn't in galaxies at all. It's floating out in this supposed void. And it's not just atoms. This space is shot through with magnetic fields and flooded with radiation, from high-energy cosmic rays to the faint, constant afterglow of the Big Bang itself, the cosmic microwave background. This ancient light fills every single corner of the cosmos, which means no part of the universe is ever truly dark or without energy. On top of that, you've got ghost-like particles called neutrinos streaming through everything, and the mysterious substance we call dark matter, which outweighs all the visible stuff combined. Even the loneliest voids are packed with these invisible ingredients. Slow, dramatic beat. So on the grand scale, space is less like an empty box and more like a thin, celestial soup. But this is just scratching the surface. What if we could magically scoop all of that out? Every last atom, every photon. Would we finally get our perfect empty void? The truth is far stranger. All right, let's picture our perfect box of nothing. We've managed to remove all matter and radiation. It's the purest vacuum you can imagine. And yet, it's still not empty. Because space itself, the very fabric of reality, isn't just a background. It's structured by things we can't see, like fields. You already know some of these, like the gravitational field that warps space-time and tells planets how to orbit, or the electromagnetic field that carries light. But there's another, stranger field that soaks every single point in the universe, even in a perfect vacuum. It's called the Higgs field. The Higgs field is often described as a kind of cosmic syrup spread throughout all of space. For a particle to have mass, it has to interact with this field. Particles like photons, which have no mass, zip right through it, which is why they travel at the speed of light. But other particles, like the electrons and quarks that make you and me, are constantly dragging through the Higgs field. That drag is what we feel as mass. It's the resistance a particle feels when it tries to move. Without the Higgs field, nothing would have mass, atoms would never form, and, well, we wouldn't be here. So even in our perfectly empty box, there's an invisible architecture, an energy field that is always on, everywhere. This discovery was so important, it won a Nobel Prize. It proves that empty space isn't just a passive stage, it's a main character in the story of the universe. But this isn't still the deepest level. To find the real truth, we have to go smaller, much, much smaller. And what's waiting for us down there is the true heart of the cosmic lie. Welcome to the quantum realm. Down here, at the smallest possible scales, the rules of our world don't just bend, they shatter. And the biggest rule we're about to break is the idea that anything can have zero energy. In quantum mechanics, that's forbidden, thanks to the Heisenberg uncertainty principle. In simple terms, the uncertainty principle says there are fundamental limits to what you can know. A lesser-known version of it says you can never know the exact energy of a system for an exact amount of time. What does that have to do with empty space? It means that even a perfect vacuum can't have exactly zero energy. If it did, we'd know its energy, zero, and its duration, forever, with perfect certainty, which the universe simply does not allow. So even a total vacuum must have a minimum amount of energy. We call it vacuum energy or zero-point energy. So where does this energy come from? This is where it gets wonderfully weird. This energy allows particles to spontaneously burst into existence from absolutely nothing. They're called virtual particles. For a sliver of a second, a particle and its antimatter twin can pop into existence, borrowing their energy from the vacuum. Then, before the universe can notice this cosmic theft, they crash into each other and annihilate, paying the energy back. This isn't just a wild theory. We can measure the effects of these quantum fluctuations in phenomena like the Casimir effect and the Lamb shift, which prove the vacuum is alive with these fleeting ghosts. Now, let's zoom in, way in. Imagine we could magnify a patch of this vacuum down to the smallest possible scale in physics, the Planck length. We wouldn't see a smooth, calm nothingness. We would see a chaotic, violent, bubbling cauldron of reality. The physicist John Wheeler called it quantum foam. He described it as a turbulent mess where space and time themselves become a frothing foam of tiny, fleeting bubbles. Inside this foam, virtual particles are constantly being born and destroyed. The energy spikes are so huge, they might be tearing open and sealing tiny wormholes and extra dimensions that flash in and out of existence faster than we can comprehend. Slow, powerful beat. So think about what that means. The very foundation of reality isn't solid ground. It's a violent, unpredictable storm of potential. The emptiness isn't empty. It's a chaotic dance between being and not being, a realm where the laws of physics are being pushed to their absolute limit. This is the deepest secret of the void. So we started with the simple idea, empty space, and peeled back the layers. First, we learned that the vast oceans between galaxies aren't empty at all, but are filled with a cosmic fog of particles, radiation, and dark matter. Then, we took all that away and found that the vacuum itself is structured by invisible fields, like the Higgs field, that give particles their mass. And finally, we dove into the quantum realm and found the most shocking truth. The vacuum is a seething, bubbling storm of virtual particles flashing in and out of existence, a quantum foam where space-time itself